My name is Brian Penfold from Sonoma Technology. And before I introduced our presenter, Hillary Hafner, I just wanted to go over a couple logistical points. First off, all of your guys' phones are muted. We have a fair amount of people on the line, so we didn't want to overwhelm everybody with talking at the same time. So if you have any questions or comments, please use the questions and chat box. As we go through the presentation, I will be collecting questions. The presentation is going to go about 30 minutes, so we'll have plenty of time at the end for Hillary and I to address those questions. This webinar is being recorded, so if you're having any logistical issues, or if you have to step out during the webinar, don't worry. You'll be receiving an email from me, Brian at sonomatech.com, within the next few days that will provide a link to not only the complete recording that's going to include the slides and the audio, but then also a PDF of just the slides by themselves. And that should be coming in the next couple days. And like I said before, if you're having any trouble with the webinar, please refer to the GoToWebinar help link in the invitation email or on your screen. And that can hopefully walk you through the process. If you're continuing to have problems, not to worry. Like I said, the webinar will be recorded and you'll have access to it in the next couple days. I think with that, I'm going to turn it over to our presenter, Hillary Hafner, and if you guys have any questions, just feel free to use the questions box as the presentation continues. Thank you. Hillary?
Hello, everybody. Hopefully you can hear me fine. I always prefer to see your faces so that I can tell if I need to say something separately, but I'll do my best to lead you through this presentation. A little bit about me. I'm a Senior Vice President here at Sonoma Technology, and I manage the Emissions Modeling and Analysis Division here. And I've been here a long time, since 1989. I really enjoy working with agencies and the EPA to help investigate air issues. Try to be real practical and straightforward since I'm a chemical engineer, so that's sort of the way my brain thinks. What we're going to be talking about today is some best practices and analysis insights on monitoring network assessments. And this is really coming from the fact that we recognize it's hard for many people to travel these days to conferences. And so we thought we'd conduct this webinar, which is essentially covering the talk that I gave at the National Ambient Air Monitoring Conference recently in Atlanta, and it was part of a network assessment training session. And one of the things I've added into this presentation, because I saw a few people that I remember being in my session, but I've added a few things here and there from some of the other presenters to put this presentation more in context. Because as you can imagine, I was part of several different presentations, so I've added a few things. So it's a little bit new for those that who saw me before. One of the things that we'll provide a link to in the resources slide that we have is that all the presentations are currently now on EPA's AMTIC website. So you can go back and look at the other presentations that I'm somewhat recalling some of what they did. All right, so a little outline here on what we're going to be covering today. I've added a little bit of background information. We're going to talk about a conceptual model of network assessments. We'll present a little bit about the most commonly used analyses. We're going to show a couple of slides on visualization and then talk about some analysis insights and give you some resources. I want to walk through this diagram that we have here, though, because it's really the steps that we take in performing a network assessment. And the first step is a pretty thorough examination of the sites and monitoring objectives that you have. So it's like, where are you monitoring? What are you monitoring for? And then why are you monitoring? What are the goals that you're trying to meet with your network? The next step, once you've gathered all that information, is to develop a conceptual model. And I'm going to talk about that in a little bit later. You take the information that you've gained from this conceptual model, and then you perform some analyses that test whether or not your monitoring network is meeting those objectives and the conceptual model that you've come up with. Once you've done those, you develop some recommendations to potentially adjust the network if it's needed. And then, we're usually, involved with these first 4 steps. And then it's up to the agency, and obviously you would be performing all of them if you're doing this on your own. Steps 5 and 6 are really who's in charge of that network needs to then assess what other considerations they might have. Sometimes you would like to maybe remove a site, but politically you cannot. Or you also would like to add some things, but you don't have the finances to do that. Those are what we mean by other considerations. And then hopefully get permission to implement changes. So that's just sort of the flow that we have. So a little bit of background. The network assessments for the U.S., the EPA is requiring that every 5 years that we need to do an air monitoring network assessment. That's different than the monitoring network reports that are done annually. They're quite different, every 5 years. And you could say that similar guidelines that we're going to be talking about here can also be used in non-regulatory networks. So it doesn't just have to be meeting what the EPA is asking for here. But the typical questions that people are trying to address when they're conducting these network assessments are basically things like, is my monitoring network meeting the goals that we've established? And over time, sometimes those goals change. And so this is that every kind of 5 years to really look at that. Often we might need to add new sites because of changes that we'll talk about with new emission sources in your area or population centers that are growing or shrinking. Are some of the existing sites no longer needed? And that can be, again, from changes in air pollution concentrations that have been going down over time, or that those sites are no longer near an emission source that was important a few years ago. And then as you're finding, there's a lot of new technologies coming on the market these days, and might some of those new technologies be appropriate for using in your network? What about all these new low-cost sensors? How could we maybe use those? We've worked with several agencies or non-governmental organizations in Canada, and there's been a lot of those network assessments being conducted to look at whether the monitoring goals that are being set in these airsheds are being met, because there's been a lot of growth in local industrial activities. We're also seeing that, of course, in the U.S. in the areas that have a lot of oil and gas and fracking and things like that. The assessments really are looking at how do you maximize your resources, hopefully reduce redundancy that you might have, and then also really taking this longer-term thinking. So a little bit more background here, and I took some notes at the conference that I wanted to share as well. Basically, EPA talked about that the assessment is a tool to encourage agencies and stakeholders to evaluate the present and to plan for the future. And, that really you're trying to present a case to your stakeholders, your communities, presenting the case for where you might either add things to your network or remove them. And I have a direct quote here from Lou Weinstock, who gave he was the sort of running this training session, and I really liked it because there's been a lot of pushback to EPA about doing these network assessments. And he said, a successful assessment can be completed without complex statistics. But what he thought, what is needed is a basic analysis of current air quality and trends, a thoughtful evaluation of your agency's needs and priorities, your understanding of what these EPA requirements are, and a dose of creativity, insight, and imagination. I really liked that. So I wanted to include his quote here. Some other notes that I took from the meeting were that EPA was really saying there's a lot of freedom in the format that you can put these reports together, and they just wanted you to work with your regional representatives. There were some great examples in some of the presentations. If you go to the website, to AMSTEC that has all the presentations from this conference, of different approaches people have taken to sort of scoring how well their sites are meeting their objectives. And the other thing, Lou had mentioned that they found that some of the best network assessment reports were those that included a really good executive summary up front, a couple of pages that just focused on here's what we're going to add, here's what we're going to replace, and here's what we're going to remove. And so it's just a real, a simple overview of what's going to happen, and then you can have the details later. And then finally, also in the resources page, if you go to the EPA's network assessment section in AMTIC, there is a detailed list of sort of step-by-step thought process on the network assessment and a guidance document. So there's a lot of material that you can go to. So I promised I'd come back to conceptual model, and really what we're talking about here is that essentially it's the first step. By reviewing where your sites are, what they're monitoring, what your monitoring objectives are, what the rules are, how many sites you need for certain size population, et cetera, and then other supporting data, which for us we do lots and lots and lots of maps and tables of things. You're basically trying to look at the information that you have available, and the first step look without doing any analysis is just to sort of assess whether or not your network is meeting your monitoring objectives. Are you taking the right measurements in the right places? Are there gaps in your network just by looking spatially at the information you have and where population centers are? And you can see a lot from these initial stages. It really helps you do an initial identification of gaps and possible redundancies. And you can make some preliminary recommendations on how you would modify or enhance that network to better meet your monitoring objectives, and kind of leads to then what analyses do you need to do to then sort of test whether or not your conceptual model makes sense and test your preliminary recommendations. So it's a really, really good way to get started. So let's go to a little bit of an example. This is from some Wyoming work that we did in the last go-around 5 years ago. And this is a kind of complicated map here, but basically we're looking at meteorology here, and we're going to build on this particular map later on. And there are some large arrows that are essentially showing you the annual average sort of predominant wind direction. And the sort of shaded areas around the wind roses that are shown are giving you kind of the area of influence based on that annual wind average. It's essentially, sort of how, how fast the winds are, and sort of kind of looking, if you will, sort of at the area of influence around those sites. And we're going to build on this later. But just from looking at this map, you can see that there's a big gap, where it says Sweetwater. So big gap all through that area where there's really no meteorological information. And also, I should say that where we're showing meteorology here, that's where the monitoring sites are currently, or were currently at that time. And so this was just giving you an idea that we're going to have to add a lot of other information. What if there's a lot of population in that area where there's no monitoring? Then that would be a clear gap in monitoring to protect people. And one of the things that we've learned over the years is that working with the agencies, you usually have a very, very good sense of what's missing or what's over-monitored and what changes that you'd like to make. And by going through this process, it just sort of it validates your thought process and your knowledge. You know a lot about what things you want to change. So some of the supporting data goes along with both. It's sort of a dual purpose. You can use it in your conceptual model development, and then you can use it for your follow-up analyses. So several bits of data here that we've seen being used are, population, of course, population density, but also changes in population that are projected or have occurred in your area. What population centers are growing, and in some cases, what ones are shrinking. We also do lots and lots of maps, and one of the examples I really liked at the conference was that someone had taken the spatial scale of the sites and overlaid that with census tract information. So you have a neighborhood scale site, or you have a regional site, and you can put, EPA has a table of the, what that scale of representativeness is. And so that was a very clever way to look at the data. You can also look at emissions, where, if you're lucky enough to have some gridded emissions, that's great, but sometimes it's just where are the emissions occurring? You know, and then you can also look at what have the trends been sort of over time of the emissions in your area, or the emissions types in your area. Meteorology is really important. We use that a lot because air moves, and so we want to be looking at, you know, sort of what is moving into your area with predominant winds. Is that, you know, are your sites upwind or downwind of major emission sources? Another set of data that has been used over the past, and again, there were some nice examples at the conference. We're looking at sensitive groups, so environmental justice areas. One researcher used asthma hospitalization that they were able to obtain at a zip code level. You can look at sensitive age groups, you know, younger or older folks that would, you might want to, maybe aren't monitoring near where you have, you know, a retirement home or something like that. Land use is another one that's useful to use. And then, again, if you're lucky enough to have this, sometimes modeled future year concentrations from a state implementation plan or some other modeling, you know, a modeling exercise that would show where the concentrations, where the highest concentrations are occurring, is sort of shifted over time. So, well, if you've ever looked at the guidebook, it shows, I don't know how many, I didn't go in and count, 15 or 20, I mean, it's a lot of different analysis approaches. We seem to have tended to do 3 of them frequently. The population area and emission served, which I'll show you some examples of, really helping to characterize sort of how the sites are covering your population and the area of, you know, sort of the spatial distribution of your sites. Correlations, which essentially are helping you try to identify potentially redundant monitors that you might have maybe over-monitoring in the area. And this is the case where maybe you might want to move a monitor in an area that's less monitored. And if you show that the concentrations are correlating, then you're not losing anything by moving a site potentially. And then with suitability analysis, we're finding really helps bring everything together. And again, I'll walk through how we've done that, but you're essentially developing some weighting schemes to identify areas that would be most suitable for monitoring locations based on a range of information that you can essentially grid up and layer and give different weightings to different layers to look at, let's say, population or emissions or how close you want to be to roadways or how far away you want to be from other monitors, et cetera. Like I said, there's a long list of possible analyses, but we tend to focus on these, at least initially. So one of the building blocks for these areas served or populations served are called heaps and polygons. And if you just sort of walk through the top graphics, first of all, you start with where are your monitoring sites. And in this case, there's a red line indicating the airshed that we're looking at. But you'll notice that we're showing monitoring sites on the other sides of these barriers. Sorry, not barriers, but of these political lines, if you will. And then the next thing is to essentially, you're drawing a line halfway between the different sites. And so, and it's sort of a blow-up of that is down at the bottom where you can see let's say, the dots representing monitoring sites. And if you look at 2 different monitoring sites, you'll see that there's a line halfway between, those 2 sites. So every 2 sites that you look at, you'll see a line halfway between. I know that's not a real statistical way to describe that, but that's just the practical way of looking at it. Then what you can do once you've drawn these polygons is then you can overlay population density information or emissions density information. And in the far right-hand map, basically that was the result of what the total emissions were in those heaps and polygons. And so that gives you some sense of the population that's covered by the particular sites within each of those polygons. So let's look at one that's very, very colorful here, and I'm going to walk through sort of the pieces of it. So first of all, this is a study area in southwest Wyoming, and we're looking at the heaps and polygons here, and they're each colored, and they're centered. You'll see there's a yellow monitoring site in each one. So there we go, this is the Jonah site. or at least was 5 years ago. And those teeth and polygons are then colored by the population represented by each of those polygons. So we've got a site which is within a polygon, and now we've added population density essentially to that. How much population is covered by those, with the red being the most populated and the dark blue being the least populated of those polygons. And then kind of another layer behind that, you see sort of these graded blue colors, and those are essentially the block population per square mile. And so that gives you a sense of, you can see where there's more population, less population. One of the things I wanted to point out about this is that there are physical barriers that you can't represent with these teeth and polygons that you have to do either in looking at the maps later or build in, make some changes to these polygons. So for example, if you look at the Boulder one, that one, yep, and the one above it, there is something called a continental divide in between. There's a very high mountain range that you can imagine that up on the other side of the mountain range, so right there, yes, that those parts of the polygon are clearly not represented by the sites across on the other side of that mountain. So there is some interpretation that you need to be aware of. The same thing is going on in the big green one over there for the Daniel South. And you'll see a dark gray area. There's actually a significant amount of population on that side of, again, of a mountain range. And there is no monitor over on that side. So that would be, you start looking at, well, where are some underrepresented population areas that aren't very well covered by the existing monitors? And so that's what the 3 big gray boxes are. Again, this is with no other, this is doing some analysis, and this is sort of, but there's, right now, it's really just looking at the map and seeing where there's some gaps. So if we go to the next one, we can do the same thing with emissions. And in this case, it's just the location of emissions. We don't have the emissions amounts. So this is a qualitative based on location of emissions, not on the quantitative emissions amounts. But remember the white blobs that we had from an earlier map that shows sort of the area of representativeness based on wind direction and wind speed are overlaid now here. And you can see some areas where there's a lot of emissions, but we don't, but that we're not covering very well. And again, this starts looking at if we're trying to do representative emissions information, there might be some locations where there could be some additional monitoring. And we're going to now, as we're doing these series of analyses, you're going to start kind of ranking, well, these sites do well for population, this site does well for emissions, and you start kind of getting some rankings of the different sites and their usefulness to meet your objectives. So one of the things that, some of the things that came out of this map, just a couple of them, was that oil and gas development had encroached onto the Jonah site, and so it had become, it used to be a downwind, like they wanted to be sort of a receptor site, but it had turned into a source site, and I think subsequently that site was actually moved. And then the South Pass site, which you can see sort of, yeah, right there, that site is pretty far removed from oil and gas production. And it may be fine for whatever the objectives are for that site, but it's just if that was a site that you wanted to really look at impacts from industry, it wouldn't be very representative. So again, in this case, we're just looking at location, not the emissions amounts. Another typical analysis that's done if you have enough sites in your network. If you only have a couple of sites, you usually wouldn't do a correlation analysis. But this is actually an example from Canada where there's a lot of passive sampling that occurs. So basically you do like a 2-week average, concentration based on just, filters that are set out. And you can do a lot of spatial sampling, right? You can set, they're not super expensive. You can set them out all over the place and then look at what the concentrations come out. It's really helpful for finding sort of hot spots and, spatial trends in data, long-term, trends in data. So this was an ozone network, and what you can see here, without seeing any of the numbers or seeing any of the names of the sites, is that any correlation between one site and another that was greater than 0.9, we've colored dark, dark reds here. And so you can see that there is a lot of redundancy at these sites, which really, if you're thinking about a 2-week average, may not be surprising for something like ozone, which is pretty, spatially, can be somewhat spatial homogeneous depending on other emission sources. But over a 2-week period, you're going to see a lot of redundancy here. So one of the examples here would be that this is an opportunity for reduction that might free up funds to monitor other pollutants, particularly other pollutants that might be more spatially variable. I'll show an example of another correlation analysis a little bit later. All right, suitability analysis. Again, this is it can be somewhat complicated to think about, but this is done in a GIS platform. But basically, suitability modeling is kind of bringing all these things together, where we're looking at how do we identify suitable monitoring locations based on different kinds of criteria. You can ask a lot of what-if questions. So if we look at the top line, we're going to have input data from, let's say, the points would be like a monitoring location. Lines might be roads, population density, and then you can even build in elevation, for example. Then what you're going to do, all of these are in different formats and different, they're different things, right? A point versus a line. So then what we do is we grid the data to create sort of density plots or distance contours, and this is all can be done within the GIS. We then reclassify each of those sets of data to make them all on the same scale, like 0 to 10. And what we're going to do then is we're able to add them together, layer them together, give each set of data a different weighting. Like, okay, we're going to, from 0 to 100%, we're going to say we really want population to be important. We might weight it, like, let's say it's 40%. And so, again, the GIS then can add these things together with those weightings, and we're going to get a resulting map down at the bottom, which would basically show you the suitability based on your what-if scenario, your ranking, so your weighting of each of the layers and the importance of them, to show you to meet that particular objective, you're going to get a map that shows highly suitable to more low suitability. And you can build in a lot of different information. This will be things like emission source influences, want to be closer to or farther away from certain kind of sources, how close are you to populated areas. You can look at land use. I want to be on an urban versus rural. How about site accessibility? Is there power? So you can overlay almost anything you could grid, you can then have as part of your list of layers that you would have. Now, once this is done, you're going to, you've gone through different scenarios, and you can kind of tweak the scenarios. You're still going to have to then, at a very fine scale, go out and find the right location. Do you have access to that land? Who's it owned by? So you can get on a pretty fine scale here, but you're still going to have to do some legwork if you're going to try to find the right exact location for a monitoring site. But this gives you the general areas in which you would be looking. So a couple of examples, some suitability analyses that were done for Southwest Wyoming. Again here, we were looking at if you wanted to add hydrocarbon data to sites or NOx and PM data to the sites, and these weren't being currently measured at these locations. One of the questions that was going on there, let's look at population exposure. And then we did some suitability modeling, and there's some red circles outlining areas that have population that did not currently have hydrocarbon or NOx PM2.5, PM10 monitoring. And it was an area that if funds were available to be able to put in those kinds of monitors, those would be the population areas that when we want to look at first. So I guess I could have included this slide in the part on correlation, but we just want to talk about there's all kinds of different ways to visualize data. And so this was a map for a recent Florida network assessment where we're looking at 8-hour daily maximum ozone and the number of sites that correlate with other sites at an R squared greater than 0.8. And so there's a proportional symbol circles, essentially, that have the number of correlations with other sites. And there's a couple things to note here is that sort of in this central Florida area, there's a lot of sites, and they're pretty highly correlated. And so therefore, there may be some redundancy in this area. But the other thing to note is all along the East Coast and then up in the Panhandle, you can't even really see the dots because those sites are not correlated with other sites. So this is just a way to sort of show both the ones that aren't correlating with other sites, and so they're pretty important because they're unique, and then the sites that tend to be much more highly correlated. So it's another visual way to sort of show a correlation analysis. Another thing in this case, in addition to the GIS-based tools, which I've been mainly focusing on, most of you should have access to AirNowTech. If you haven't checked it out, it's pretty amazing, airnowtech.org. But there's a handy tool within AirNowTech Navigator that can now allow you to do both wind and pollution roses. And that's sometimes been an issue for people out there to be able to relatively easily create those kinds of diagrams, and they're useful. As you can see, we were using meteorology quite frequently in some of these analyses. So this is just a place that you can go to do those wind and pollution roses. This leads to some insights here. One of the things that takes a lot of work up front is verifying all the site maps and tables and kind of multiple iterations to make sure you're really capturing all the data that's being measured. And this means considering sites both in and out of your control, because you may have, you may be in an air basin or, whatever, an airshed, that there might be some nearby sites. You need to think about them in your process. And while you can't tell them to be removed or added, you can or add things to them, you at least need to know they're there. And so it's important to have that. And so that's one of the things that often comes up. It's really hard to kind of figure out where all the sites are in the area that you're looking at. Another thing that's come up is that you have to be really careful in your wording, because often there's multiple stakeholders. You might have public evaluation of your network assessment report, and you have to be careful that you're really not promising new monitors or monitor removal, because there just might not be the funds, or politically you can't remove something. And so it's careful, you have to be careful about the wording there. It's very important to consider meteorology, and so that's just something that we couldn't emphasize enough, because again, air moves. You want to be taking care of like what's upwind, what's downwind, et cetera. And then one of the things that I've learned over my career has been that the more analyses that you do that show the same general results, the more confidence that you have in your findings. So basically getting consensus among these different analyses really helps you build a strong case for removal or addition of monitors, because it really helps you out to have that consensus. But then the budgetary realities that we're all working under. We basically have been hearing the kind of the buzzwords at the conference were things like, this is a zero-sum game. You need to eliminate to gain, and that basically means you have to eliminate something in order to gain or add something else, right? So it's really important to take that big picture view of budget realities into account when you're thinking about the changes that you're going to try to get taken care of. And the most common issues that we've seen as far as changes to networks would be reducing redundancy, and then population areas that don't have monitoring that probably need it. So those are some of the things that we're seeing. I promised you a resource page. This is not a complete literature review or big long resource page, but certainly some places to get started. The conference presentations, here's the link to that. And again, we'll be sharing this presentation with you. AirNowTech Navigator, which I mentioned, where you can look at both data, pull data from there, and then also look at wind roses or pollution roses. There's demographic data beyond the census data. like, as I said, you'll have to look at one of those presentations that use asthma incidences from the health department that they used in their assessment to great use. And then the guidance and tools on AMTIC for network assessments. The other thing that I know that's going on is that Region 5 has been working on some R tool development that kind of built on what was done by EPA 5 years ago. And I know currently they're just trying to figure out where they might be able to share some of that tool development. Some final thoughts here. So the assessment methods can be of value in a wide range of situations, and there's certainly, we've just sort of skimmed the surface on the kinds of the most commonly used ones that we're seeing, but there may be other analyses that work better for your situation and the kinds of objectives that you're trying to look at. And then we wanted to think a little bit here about, there are some current forcing functions for monitoring networks, and what I mean by that is, what is making you really assess the future of your network and that there might be changes coming? Things like new regulations. There's a potential new ozone standard coming out this fall, right? So we need to be thinking about that. Population growth. And I did a couple times say population decline because we've actually seen that in some parts of the country or in Canada as well, but population growth. Sources, new industry, growth in old industries that have been revitalized. And then these new technologies such as the smaller, lower cost sensors. So those are things that kind of create, you to look at your data in a different way. All right, so I guess with that, you could show that again. You can show our pictures. If you don't know us, this is me on the left and Brian on the right. But we'd now like to see if did we get some questions that we need to answer?
One question that we got was where can we find some of the geographic data that we're showing in some of the maps? A lot of the population data is going to be freely available, or let me back up. The majority of the data that you're going to be able to use is going to be freely available to anyone. And population data is going to be available from the census at a variety of different geographic resolutions, depending on the type of area that you're interested in. You can get emissions, point source information, and area and source information from EPA, but it's more likely you're going to have that at either a more localized or regional scale. And other things like road networks and rail lines, elevation information, that's all going to be available from various agencies that you can download for your specific region and get it to a GIS pretty easily.
I was going to say we've also used a lot of Google Maps. Google Earth is really great to go and look at, just look at what's going on around your sites and maybe how things have changed since a few years ago. And we're looking at a couple other questions here.
We have another question. How proficient must you be in GIS to conduct some of the analyses shown? That's a great question. I think for certain analyses, some of the GIS steps are fairly straightforward. Obviously, with GIS, more often than not, there's licensing required with the software, so you're going to have that in-house. That's step number one. With step number two, there are certain analyses that will require some GIS expertise, specifically suitability analysis, where you're doing a lot more in-depth GIS calculations and processing. But for pure map display, as long as you can collect the data, you should be able to map it without a lot of GIS experience. But like I said, once you start getting into some of the additional analyses, having a GIS staffer in-house is greatly beneficial. Okay, and let me also just throw one thing out here. The questions that we may not be able to get to will be addressed and included in the downloadable link that you guys will have in a couple days. Next question. Is AirNowTech being backfilled with AQS data once, oh, it just moved on me, once validated data is loaded into AQS?
Yes, the answer is yes. For the last, not a super long record yet, but I believe for the last 2 or 3 years. And there actually should be a frequently asked question that addresses that somewhere on AirNow Tech. But yes, it is starting to be backfilled.
Okay. Another question, do you deal with the situations where airsheds don't match up with political boundaries or Thies and polygons? Yes, all the time.
How do we deal with it? Well, I mean,
yeah.
I mean it's mainly, as we said, you might not include everything. You just may not have control over those sites that are outside of your boundary, but you need to help them inform your own decisions. You know, if there's a site that, you know, you might be collaborating with, well, let me back up a little bit. One of the things that we were told at this conference was that you can do regional assessments. You don't have to just do your own. You can combine with that nearby, you know, that nearby agency and work with them to come up with a joint network assessment. And I think that that's something that might work in cases where there's really complicated politics, or, you know, where you've got a lot of sites that are kind of overlapping with each other. So that's one possible answer to that.
Another question, have you seen network reductions due to industrial reduction or source shrinkage?
Yes, indeed. I think that's happened a lot in places. You know, I know that there's been some difficulties with getting permission to remove some sites. You know, sometimes the state recognizes that there has been a change in the sources, but then they have a hard time closing those sites, sometimes because there's pressure from the area. But, you know, I think, yes, definitely. I mean, there's been a reduction in many areas of the country of certain kinds of industry, steel industry, for example. And so, you know, that definitely is part of what you're looking forward, you know, with your plan. I just know from hearing from some state folks that occasionally it's clear they need to close the site. It's been below the NACs, et cetera, and they've just, depending on that region or that state, they have a hard time getting that site shut down. Okay, so then there's a question here. Some areas are moving into their first 10-year maintenance period and some in the second 10-year maintenance period and have monitors in places to measure continued attainment of the specific NACs. Do you see any alternative to continued monitoring for 20 years? I'm not sure I really understand. I think again, I think there's going to be changes. We need to look at what the policies are for, you know, how many monitors you're supposed to have of certain pollutants, you know, to meet the NACs. I think that's what it is. Maybe you might want to send us an email with a little bit more detail about what you're asking there, and we can do a better job of answering it later. Any other questions?
And I think that has the list of questions that are covered. And like I said, if you have any additional questions, feel free to contact Hillary or I by email, which is shown here on the last slide of the presentation. And with that, we're ending a little bit early. But we will be, like I said, you'll be receiving an email from me, brian@sonomatech.com, with a link to this presentation in just pure PDF form, and then also the complete recording with the audio as well.
We appreciate you all sticking with us here and listening, and hopefully you learned a little something, and we're happy to try to answer questions for you. So that's why we've got our contact information here.
Okay, with that, I want to wish everybody a good day. Thank you. Bye-bye.